Solutions to Mock Exams 2003. The first equation has an unknown power. To solve this, we need to create a common base. Writing 4 to the power of x as 2 to the power of 2x and 1 as 2 to the power of 0, we can use the law of indices. 2 to the power of 2x minus x minus 3 equals 2 to the power of 0. This gives us 2 to the power of x plus 3 equals to 2 to the power of 0, and equating the power, we have x equals -3. We can also think of the left hand side as a fraction, and multiplying the denominator to the right hand side, we have an equation 4 to the power of x equals 2 to the power of x minus 3, and again we create a common base of 2 and equate the power. 2 to the power of x, 2 to the power 2x equals to x minus 3, giving us the same answer, x equals -3. In the next question, we need to bring 16 to the right hand side and create a common power of 4. Once the power is equal, we can equate the base, giving us x equals to 4. In the next sum, we have one fraction equals another fraction. In this case, we need to cross multiply, and when we cross multiply and expand, we can see that there is an x squared term. This means that we have a quadratic equation. 2x squared plus 5x minus 12 equals to 0. To solve this equation, we need to factorize, giving us -3 and x plus 4. So we have two solutions, x equals 1.5 or -4. In question 2, we have an expressions that have different bases. In order to solve this, we need to create a common base of 2 and 3 by writing 4 as 2 to the power of 2 and 6 as 2 times 3, 18 as 2 times 9 or 2 times 3 squared. Next, we expand out the power. Now we can make use of the law of indices. That is 2 to the power of -8 minus 2 times 3 to the power of -2 minus 4. That gives us 2 to the power of -10 times 3 to the power of -6, which is 1 over 2 to the power of 10 times 3 to the power of 6. A sum on standard form can easily be calculated using the calculator. We can rewrite this as 5 times 10 to the power of 4 plus 1 over 8 times 10 to the power of -3. We only multiply 2 with 4. Rewriting this, we have 1 over 8 times 1 over 10 to the power of -3. which gives us 0.125 times 10 to the power of 3. And simplifying this, we have 5.0125 times 10 to the power of 4. In question 3, we have factorization by grouping. Each group has a common factor. In the first group, the common factor is 2a, and in brackets we have a minus y. The sign in the middle is negative, so we bring down a negative sign, and a common factor of x is factorized out. And since the factor in brackets is a minus y, the second factor must also be a minus y, so that we can continue to factorize out a minus y, leaving behind 2a minus x. The next example is a difference of two squares, that is 3x square minus 5 square, which gives us 3x minus 5 times 3x plus 5. In the next question, we have algebraic fractions. In algebraic fractions, we need to examine the question carefully. In this case here, the first fraction has the x in front and the second fraction has the x behind. So what we need to do is to change the order so that the x is in the same order. To do this, we need to change the sign and then change the order of the denominator. Next, we need to factorize the denominators. And then we need to create a common denominator. Since we do not have x plus 3 here, we multiply by x plus 3 over x plus 3. And on this side, we do not have 2, so we multiply by 2 over 2. Once the denominators are the same, we can put them under a single denominator. We keep the denominator in factorized form, expanding the numerator. We have minus x minus 3. Please do not forget to change the sign when you open up the brackets. This gives us 2x squared minus 5x minus 3. In this case, the numerator can still be factorized. Factorizing the numerator, we have two x plus 1 times x minus 3. As you can see, we can now cancel away the common factor x minus 3. And our answer now is 2x plus 1 over 2 bracket x plus 3. Keep the answer in factorized form. In question 5, we need to make x the subject of the formula. Since there are two subjects, we need to create only one. To do that, we first cross multiply, then we expand, and we want to collect all the terms that contain x together. That is 3x plus ax. And the other terms, we put them together, 2a plus 3d. Next, we factorize out the x so that there will only be one x. The subject must be alone. Dividing both sides by 3 plus a, we have the subject x equals to 2a plus 3d over 3 plus a. Normally, we need to write x on the left-hand side. In number 6, we have a simultaneous equation. We need to get rid of the terms in y. To do that, we need to create a 6y in the second equation by multiplying by 2. We get 6x we need to multiply the second equation by 3, giving us 9x minus 6y equals to 6. Call it equation 3. Now we have a common term in 6y. We add the equation 2x plus 9x, equation 1 plus equation 3. 2x plus 9x is 11x. 6y plus minus 6y is 0. 5 plus 6 is 11, giving us x equals to 1. We substitute x equals to 1 into the first equation to obtain the value for y. Y equals to half. Now we have algebraic equations in an equation. To solve this equation, we need to get rid of the denominator. To do that, we multiply throughout by the LCM 6 throughout. In this way, we can cancel out the denominator. And then we have the equation 4x minus bracket x minus 4 equals to 3. And opening it up, we have 3x plus 4, don't forget to change the sign, equals to 3, giving us x equals to negative 1/3. In this equation, we need to prove that the two triangles are congruent. As you can see, we have two marked angles. Therefore, this is simply a case of angle side, and they share a common side. Use the angle to determine the correct arrangement. Since A and D has the same angle, A corresponds to D. B and C has the same angle, B corresponds to C. Once we have the correct arrangement, then we can write out the equal angles. Angle BAC equals angle BAC to CDB. And angle ACB equals ACB to DBC. And finally, BC is a common side. We now have a sum on similar triangles. For similar triangles, we must first state which triangles are similar. In this case, ADE is similar to ABC. Once we have determined that, then we can make use of the arrangement to determine the known ratio. AD is 6 cm and AB is 10 cm. So the known ratio is AD over AB, which is reduced to 3/5. Once we have the known ratio, now we can find the area. Ratio of the areas ADE over ABC. ADE is x and ABC is x plus 20, and this equals 3/5 square, the known ratio square. Here we have x over x plus 20 equals 9 over 25. And cross multiplying, we have 25x equals 9x plus 180. In simplifying this, we have x equals to 11.25. In the second case, we have triangles with the same height. For triangles with the same height, the ratio of their areas is simply the ratio of their bases. Since it's not similar triangles, we do not square the ratio of the sides. We have x plus 20. Since x is 11.25, therefore we have 31.25 over y, which is the area we want to find, equals to 5 over 3. And simplifying this, we will have y equals to 18.75 cm squared. In question 10, we have a graph y equals to 2x squared minus bx minus 5 passing through a point c equals to minus 1, 0. Now when a curve passes through a point, the point can be substituted into the equation in order to find the unknown b. So here x is -1 and y is 0, and substituting into the equation, and simplifying, we have b equals to 3. And once we know the equation, we can use the equation. The equation is now y equals 2x squared minus 3x minus 5. Now we want to find the coordinates of A and B. A is the y-intercept. The y-intercept is minus 5. So the coordinates of A is A brackets 0, comma, -5. In order to find B, B is an x-intercept. And to find x-intercepts, we need to equate the curve equation to 0 and factorizing it, this gives us x equals to, factorizing it, we have x plus 1 and 2x minus 5 equals to 0, giving us x equals to negative 1 and x equals to 2.5. Therefore, b, which is on the positive side, must be 2.5, 0. Next, we want to find the gradient of AB. Since we have already found the coordinates of B, which is 2.5, 0, and A, which is 0, minus 5, then to find the gradient, we take the difference in y, which is 0 minus 5, over difference in x, which is 2.5 minus 0. This gives us a gradient of 2. The equation of the line AB is found by using y equals to mx plus c, where m is the gradient. Therefore, m is 2. The y-intercept is minus 5. In the next sum, we are given that the total surface area of a cylinder is 16 pi. When a question gives you a value in terms of pi, usually it is being cancelled away. Writing out the formula for the surface area, we have 2 pi r square plus 2 pi r h equals to 16 pi. Since the height is given as 2x plus 3 and the radius as x, therefore we have 2 pi x square plus 2 pi x times 2x plus 3 equals 16 pi. Dividing throughout by 2 pi, we have x square plus x bracket 2x plus 3 equals to 8. And simplifying this, we have 3x square plus 3x minus 8 equals to 0. In the second part, we are asked to solve this equation. To solve this equation, we need to use the formula x equals minus b plus minus square root of b squared minus 4ac divided by 2a. Our a is 3, b is also 3, and c is negative 8. We need to show the substitution into the formula, as this carries some marks. For AC over 2A. And this works out to be 1.21 and negative 2.21. We reject the negative value because x is the radius and it cannot be negative. In the next sum, we need to find the perimeter and the area of this figure. In order to do so, we need to find the angle and the radius of the sector. The radius of the sector can be found by using Pythagoras theorem. And the angle can be found by using tangent. We first find the tangent of the angle here, 4/5, and the angle is okay. Once we have found the angle, then we can take 180 minus these two angles, which gives us this angle here. We call it alpha, and alpha is found to be about 102 degrees. Once we found the angle and the radius, then we can find the area of the sector. So the sector area is 102/360 times pi r squared. And once we have done that, then we add the area of the two triangles, which is half base times height, half 4 times 5. Therefore, the total area will be, there are two triangles, half base times height, plus the sector area. And to find the perimeter, we need to find the length of the arc and add to the three sides here. We have total perimeter is the arc length, which is 102 divided by 360, 2 pi r, and plus the remaining lengths, 4 plus 10 plus 4. In the next question, first we need to find the angle CAB. As you can see, there is a right angle triangle with two sides known. This side is 12, therefore AB is also 12. Therefore, we can find this angle, call it theta, by using tangent. 5/12, and tangent is 22.6 degrees. Next, we need to find EF. To find EF, we need to find the length CF. And to find CF, we need one side and one angle. The angle that we need is this angle here. And this angle is the sum of these two angles. So angle CFB is simply 52.6 degrees. Once we have the angle and the side, we can find CF. 5/CF is sine 52.6 degrees. Once we have found CF, then we are ready to find the length EF, because EF over CF equals to sine 30. Okay, and in question 14, this is a graph question, and usually a graph question asks the same things. First, we are asked to find the values of x when y equals to 4. We simply draw a line y equals to 4, which cuts the curve at 2 points, and we read off the values of x. X equals to about 1.5, sorry, is 2.15, and minus 1.65. Next, we need the gradient at negative 0.5. To do that, we need to locate the point on the curve where x is negative 0.5, and then we need to draw a line, a straight line, passing through this point. Using the straight line, we need to draw a triangle to obtain the gradient. The gradient in this case is negative 3. Okay. Next, to solve the equation from the graph, the solution to the quadratic equation is simply the x-intercepts, which is at x equals to 1.5 and minus 1. And the line of symmetry is simply averaging out the x-intercepts, which is 1.5 plus negative 1 divided by 2, giving us 0.25. Okay, this line is x equals to 0.25, the line of symmetry. And to solve the equation 2x squared minus x minus 3 equals to 2x, we need to draw a line y equals to 2x. And to draw this line passes through the origin, and we can create another point by taking x as 1. So when x is 1, y is 2. So we plot the point 1, 2, and join it to the origin, giving us the line y equals to 2x. And once again, the solutions are just the x values at the intersection points. Okay. This completes the solutions to the 2003 paper.